So you can see what I simply put here is another form, still the same thing as the energy profile diagram in the note earlier. This is another form. So a reaction which heat is given off, is said to be exothermic. So when you look at it here now, in such reaction, if you deduct your reactant, the heat of the reactant from that of the product, your answer will be negative, because the heat of the reactant will be higher than the heat of the product as shown in this profile diagram. So notice that in an exothermic change, the product have a lower energy than the reactant. The energy that the system loses is given out as heat. So the surroundings warm up. I said it the other time that when you touch the beaker, it will be hot, showing that heat is being given up. So that is what we have here, that the surroundings warm up. Now, a reaction in which heat energy is absorbed is said to be endothermic. So what we have here is also the energy profile of endothermic reaction. You can see now that the product is up while the reactant is below, which means that the value of the heat content of the product is higher than the value of the heat content of the reactant. So when you subtract the heat content of the reactant from the heat content of the product, then what you will be having will be positive. That is, your delta H will be positive. Now this time the product have a higher energy than the reactant. Now the system absorbs this extra energy as heat from the surroundings. So you can see expressing the exothermic and endothermic changes in number. Now if you look at, when you look at your reaction, probably from your textbook, you can look at textbooks online. If you are reading, you just see that they will write equation just like the one I have here. This reaction between carbon and oxygen now giving us carbon 4 oxide, and you can see that what kind of reaction is this? It's a combustion reaction. I told you, when you are reacting anything with oxygen, what you are doing is combustion. I remember back in SS1 I told you that if for instance I said combustion of a paper, it means that paper plus oxygen. So in this place now, what is happening here is combustion of carbon. So we are reacting carbon with oxygen to form carbon 4 oxide. And earlier I told you that combustion is a good example of exothermic reaction. So you can see in front of the reaction here we put delta H equals minus 394 kilojoule per mole. So when you see such value, when you see a negative value in front of any chemical reaction or equation, then you should know that that particular reaction is exothermic reaction. So in this case, delta H is negative, which shows exothermic reaction. Now they said this shows that 394 kilojoule of heat energy are evolved. That is, when we say evolved, given off. So when equation quantity of carbon and oxygen combine to give carbon dioxide, the per mole that you see there refers to the whole equation in mole quantity. The reactant, that is your carbon and oxygen, have lost energy during the reaction. Now here is an endothermic change. When you look at this one here, in this place, this is decomposition reaction. Now decomposition reaction is also an example of a endothermic reaction. So you can see here that delta H, you can see positive there. So in this case, 178 kilojoule of heat are absorbed when 1 mole of calcium carbonate reacts to give 1 mole of calcium oxide and 1 mole of carbon dioxide. So this is just a simple profile diagram to show. At times you can be given equation and they will ask you to draw the energy profile diagram for that equation. Now the first thing you must do is, one, you must be able to deduce from the equation first the kind of equation. Is it decomposition? Is it combustion? Is it dissolution? Then from there, thank God you already have types of chemical reaction in your notes. So from there, you will be able to classify them into either exothermic reaction or endothermic reaction. Then from there, you can now draw the energy profile diagram. So like this one now, I know definitely that decomposition is an example of endothermic reaction. So I know that my reactant will be lower and my product will be higher. So the reactant here, the calcium carbonate CaCO3, you can see it down, and then the calcium oxide and the carbon 4 oxide, which is the product, you can see them higher in level than this. So you can be given such a question. So take note. Now the product have a higher energy than the reactant. Energy has been gained by the system, hence the positive sign. Measurement of heat change. Now, the instrument used for measuring heat change for a chemical reaction is called the calorimeter. So this setup is just the simple setup for measurement of heat. So what we have there, you can see we have a kind of a beaker where we have been placed on a Bunsen burner. Then inside the beaker we have water. Then we are holding the beaker with a resistor stand, then with our thermometer. Then we have the insulator. So this is a kind of a simple setup for a calorimeter. This simple calorimeter is a simple calorimeter for combustion is specifically for determining the heat energy release for burning fuels. That is the energy given off during combustion. So the burner is way before and after combustion to get the mass of the liquid fuel burned. Now the thermometer records the temperature rise of the known mass of the water. You can use this system to compare the heat output from burning various fuel. The bigger the temperature rise, the more heat energy is released. So thank you. I want you to take your time to go over this note, read very well, and if there is any aspect that is not clear to you, please be free to contact me. So thank you. See you in the next class.